Hi guys, and welcome back to the AskRose Homework Help livestream. Today we're going to be covering solving linear equations. So we're going to kind of pick off where we were last week and just kind of review some of those materials first, starting with a summary of last time here in just a couple seconds. And let's see. Okay, here we go. So we're going to start with a summary of last time. So what we did last time was we learned about PEMDAS. So PEMDAS is PEMDAS, and that stands for parentheses, exponents, multiplication, division, addition, and subtraction. And that just gives us an order of things for how we work through solving equations, if we're simplifying things, or on the other hand, how to solve backwards, working backwards, if we're solving an actual equation. So I'm going to give a short little quick example problem here, just as sort of a warm-up, and that's going to be 2 equals x minus 3. So to actually solve this equation, we're going to work backwards through the PEMDAS system. So we're going to look for subtraction and addition first, because these two are kind of linked together in the same category. And we're going to see that we do have subtraction and addition. So that means in order to get x by itself, because we're trying to solve for the value of x, we're going to add 3 to the right side, and those are going to cancel. But because we added 3 to the right side, we have to keep the equation balanced, so we also need to add 3 to the left side. And as a result, on the left side we get 5, and that is equal to x on the right side. Or if you want and you like to have your variables on the left, so that way you can say, x is equal to, then we can simply rewrite that and swap their places because they are still equal to each other. And we get x is equal to 5. So next we're going to try a little bit more of a more difficult problem, and that's going to be a word problem. And so this is kind of your real-world example. So if we have a birthday party where we can invite 20 people, and I've already invited 5 of them, so how many more people can I invite? And that's the question we're asking. So we're going to find out, how many people have we already invited? Well, we've already invited 5 people. And we know that we can have up to 20 people. So we want to figure out how many more people can we invite. So if it's like how many more people are we trying to get? That sounds like an addition problem. So we're kind of looking for like a 5 plus x equals 20, where x is the number of people that we can invite because we don't know what that number is yet, right? We want to find out how many more people can we invite to this birthday party. So if we walk through the PEMDAS steps, then it's actually very similar to the last problem, where we encounter this kind of addition here first, and the way we solve for x then is going to be just one step. We're going to subtract a 5 from the left side in order to cancel out with this 5 that's being added, and if those cancel. And then we also need our subtract 5 on the other side, because this is a linear algebraic equation, and in order to do it algebraically, you need to keep both sides balanced. It's very important that we keep both sides of the equation the same. That way we're never actually really losing any of the numbers, we're just changing the way we're looking at them. And then if we do 20 minus 5, we get 15 on the right side is equal to x on the left side. So that means we can invite 15 more people to our birthday party. Okay. Next up, we're going to move to another example problem here really quick. So this is another reasonably simple problem. I'm going to zoom in just a little bit for you guys to see easier. Yes, give me just a second. Okie dokie. So our first problem is going to be 2x minus 3 equals negative 15. Now if you look in the chat, we're going to end up putting a poll, so that way you can help solve the problem, and we're just going to come up with some miscellaneous answers and then a correct answer, which you can also look at. So I'm going to be working through the problem here in just a couple seconds, but I'm going to let you guys get a head start on it if you want to be able to answer it and put your answer in the chat as a response to the poll. So I'm going to give you guys some miscellaneous answers. Whoops, I'm so sorry, that should not be... No, that should be a negative 15. That's actually going to be a positive 15. That is absolutely my bad. Okay, so that's a positive 15 there. Sorry, no negatives quite yet. So our problem is going to be 2x minus 3 is equal to positive 15. So I'm going to start working through it, and the first thing we're going to do is look at our PEMDAS order of operations. And we're going to see that first up, looking at the left side where x is, because we want to solve for x and get x by itself, we're going to see that we have addition and subtraction. And this time it's subtraction. So we are going to add 3 to both sides in order to cancel that 3, just like we've been doing in some of the previous problems. And that means on the left side we have just a 2x, and on the right side we have 15 plus 3, which is 18. And then we are going to do the next step, where as we look at PEMDAS here, we see that we do have multiplication and division, which is the next step. And multiplication and division, gotta find my pen real quick. Multiplication and division is going to be that we have multiplication on the left side. So the way that we get rid of multiplication, or we inverse it, is we divide. So I'm going to divide the left side by 2. That's going to cancel the 2's on the left side. And then I'm also going to divide the right side by 2, because, you know, we got to keep them the same. And that allows us to do x on the left side, because we canceled the 2's, is equal to 18 divided by 2, which is equal to 9. So hopefully you guys got that one right. It's going to be x equals 9. Congratulations to everybody that got it right, and if you didn't, that's totally okay, because we're going to be working through a lot more problems just like these, trying to really get you guys a feel for how to solve a linear equation, how to solve for a variable like x. I'm going to zoom in again here on this problem. So this time, we're starting a new thing. We're introducing sort of a new concept, and that new concept is the idea that we can have 2 variables in an equation. So that's a 3 equals 4x minus y, which is very important for us to, you know, be able to have 2 variables in an equation. And not only that, but to be able to solve for them in terms of each other. So let's say in this case we want to solve for y. And since we're going to solve for y, we're going to take our... So the first thing we need to do in this case is I'm going to want to add the y to both sides, because right now we have a negative y, and a negative y isn't really ideal because we're trying to figure out what is the value of y, and in this case we don't want to like multiply it by any negatives. It just gets really complicated. So the easiest way to get y by itself is actually to add it to the left side first before we do anything else, but that still follows our PEMDAS operations because we're still doing then addition and subtraction first. Whoops, that is not ideal. Okay, and we're going to do PEMDAS first. We have some addition and subtraction first. So the first thing we're going to do is add y to both sides. And so on the right side they're going to cancel. And then on the left side we are left with 3 plus y is equal to 4x. And the really convenient thing that has happened here is that now we have a positive y. So now we can actually just subtract out our 3, just like we've been doing in the previous problems. The 3's on the left side will cancel. We subtract 3 on the right side. I'm going to scroll down here a little bit, create some more room. And then on the left side, because we have the 3 minus 3, we're just left with a positive y. And on the left side, we're left with our 4x minus 3 as a separate term. So now we've solved for y. We still have variables in the equation, but that's actually okay, because we have all of our equations. We have our variable y, and then if we wanted to, we could also solve for it in terms of x just by moving things around again and then dividing by the 4. So I'm going to have you guys answer a question in the chat, and we're going to find what's called an x-intercept. And our x-intercept is just when y is equal to 0. Yeah. So when our y is equal to 0, we're going to have an x-intercept. So it's essentially a really fancy way of asking, how do we make this equation turn into 0 equals 4x minus 3? And we just want to find a value of x that makes that true. Oh, okay. So I've just been informed you do actually want the y-intercept on this problem, not the x-intercept. But that's going to be basically the same thing. Instead of that, we're going to look for a value of y where x is equal to 0. And we're going to kind of get into why we want to know that information just a little bit later in the live stream. But for now, if we're asking a question like solve for the y-intercept, what that really means is we can just plug in 0 for x. And so if we plug in 0 for x, we're going to follow our PEMDAS here. And we're going to start from the left. We've got some parentheses. We don't have any exponents, and we do have multiplication. We've got multiplication inside this set of parentheses. So 4 times 0 is equal to 0. So we've got y equals 0 minus 3. I'm going to scroll down here just a little bit. And then, really, we can simplify that too, because 0 has no value. 2y is equal to negative 3. So if anybody ever asks for the y-intercept of an equation, and we have it in terms of y, we can just plug in 0 for x, and we end up with, in this case, y equals negative 3. So now we're going to jump straight to a problem that makes that more relevant. I'm going to zoom in again to make it a little bit easier to read. Okay, so the scenario here is that I own a burger restaurant, and for every customer I have, I need to make 3 burgers. But I make at least 5 burgers every day, no matter what. So the question we're asking is, how many burgers will I make if 2 customers come into the restaurant? So the first thing we've got to do is, just like any other situation, we got to set up an equation. So we notice that for every customer, that's very important, we need to make 3 burgers. But I make at least 5 burgers every day. So that's the first information we're looking for to kind of set up our problem. So we're going to look for x, the number of burgers, or actually for connecting it to a later principle, I'm going to call it y. So y is the number of burgers, because this is going to be a 2-variable problem again, where y is our number of burgers and x is our number of customers. So the first thing we want to do is set up an equation that gets us this relationship. So we have y is equal to, well, for every customer we need to make 3 burgers. And we know that x is our number of customers. So we're going to multiply 3 by x. And then we know that we make at least 5 burgers every day, no matter what. So no matter what x is, we're always going to add 5 to whatever this number is. That way, we're always selling at least 5 burgers. So, the question is, how many burgers will I make if 2 customers come in? So something we're going to do here is set x equal to 2, because x is our number of customers, and we have 2 of them. So then we just get to plug 2 into the equation here, and we'll be able to find our value of y. So y is going to be equal to 3 times 2 plus 5. And if we actually solve that out, due to PEMDAS and doing multiplication first and our parentheses first, we're going to get y is equal to 6, which is 3 times 2, plus 5. And if we simplify that again, 6 plus 5 is just 11. So, if 2 customers come in, I need to make 11 burgers. So then we're going to ask a very similar question. That question is, how many burgers will I make if 4 customers come in? So we're going to write our same relationship as before. Our y equals 3x plus 5. And we're going to do the same thing, except this time x, our number of customers, is equal to 4. So since x is equal to 4, we can add that in by multiplying. And that means we end up with 3 times 4, which is 12 plus 5, and 12 plus 5 is equal to 17. So, because we had 4 customers come in this time, instead of the 2 customers from before, now we have to make 17 burgers. And if you notice, there's a very special relationship between these between these 2 equations. So we're asking, what if there was a way to find the number of burgers for any number of customers? No matter how many customers you get, you should be able to find the number of burgers. And so that's kind of what we're doing here with this equation. Because we've set it up that y, the number of burgers, is equal to 3 times x, our number of customers, plus 5, then no matter what x is, if we solve this, we can always find how many burgers there's going to be. And this is a linear equation, which is kind of the key point of today, is having a linear equation that we can solve. We can use it to find the answers to problems like this, where there's a linear relationship. And a linear relationship is just like if you made a line that went on a straight increase, and so in this case we're saying for every customer there's 3 burgers. So it doesn't matter how many customers you have, you're always going to have 3 times the number of customers, number of burgers, plus the 5 that we already make. As a reminder, for anybody that doesn't know, our worksheet link is in the live stream chat description, and you'll be able to click on that and submit questions if you have them and you'd like us to answer them live on stream. We're always more than happy to interrupt kind of what we're doing to help you guys tackle a problem of a similar topic, or that might kind of be under the umbrella of, in this case, linear equations. And we're always interested in hearing more feedback and hearing what you guys have to say. So if you have any questions, feel free to put them in the chat or send them our way through the worksheet form in the description. Also, we open in just about 12 minutes, and you'll always be able to call and connect with the tutor directly if we don't have time to get to your question on stream. So next we're going to introduce kind of a very major concept. So the question we're asking here is, what if there was a way to find the number of burgers that we need to make for any number of customers? So we're going to introduce something really cool, a graph. So graphs are really, really useful. So a graph is kind of like a drawing that can give us information about a problem. And a graph has a y-axis, which goes up and down vertically, and an x-axis, which goes left and right horizontally. And this is the x and the y. And if you'll notice, sort of like our problem of burgers from before, we have an x and a y. So in the case of a graph, an x sort of serves as an input. something that we're going to put into the graph, and we're going to get a y value out, which is sort of similar here, right? Because any value that we want to solve for y, we have to find a value of x. So if we plug in a value of x, we're always going to get a value of y out, and that works for any number of burgers. So what the graph does is let us visualize what those numbers are without actually having to solve for them every single time. So by graphing it, if we're able to keep graphing and find our constant rate of growth, or linear relationship here, and we can just graph it, we can ask, well, how many are we going to get if we have 12 customers, or 14 customers, or 100 customers? And instead of having to plug those in, we can just look at the graph, and the graph will have the answer for us. So it's a much more clever way of looking at that information and being able to kind of make it easier to read. So, we're going to graph that for 2. When we solved x for 2, we had y was equal to 11. And we had x equals to 4. We had y equals 17. Yes. And then we're going to do something else here, which is called the y-intercept. And just like before when we found the y-intercept, we're going to find the value of y when x is equal to 0, when customers are equal to 0. So when customers are equal to 0, we just have y equals 3 times 0, which is 0, plus 5. So overall, because 3 times 0 is 0, we only have y equals 5 when x is equal to 0. So over here, that means like if we give x some values, so this is 1, 2, 3, 4, and 5, and we give y some values, let's say 5, 10, 15, and 20, we can graph this relationship. I'm going to try and put it in red here, so that way it'll make the graphing points a little bit easier. So we're actually going to start from the bottom there, and we see when x equals 0, y is equal to 5. So our x equals 0 point, as we look along left and right, this is 1. There's nothing on this side, so this is going to be our 0 point here. So we're going to come up here, and we can make that, 0. So that's going to be our first point there, is x equals 0, is going to have a y output of 5. And then we're going to jump to our x input of 2, which is over here. And if we notice, because we solved for it before, that one is up at 11. And then, if we look for x equals 4 over here, that value is up at 17. That's kind of like if we go across here, this value ends up being 17, this value is 11, this value is 5. So the idea of a graph then is that we can draw a line essentially between all of these points. I'm sure in your own graphs they're a little bit less messy, and it's a completely straight line there. I did not do an excellent job drawing one because my graph isn't perfectly spaced, but ideally in a relationship like this you end up having a straight line that would go through all of the points in your graph that you've solved for so far. So this is a way that we can look at, somewhat reasonably small graphs, right? And we've got our 3 values here. But what if we want to find a really big value? So I'm going to scroll down here. What if there was a way to use technology to see how this works for really, really big numbers of customers? So, if you guys are following along at home and you have a computer or a phone or a tablet of some sort, I'm going to open up a website. And this website is called Desmos. And Desmos is a graphing calculator website, which is a lot of really big words that sound really fancy, but I promise it's actually really simple to learn. So I'm going to give you guys just a couple seconds here to kind of get to desmos.com. It's www.desmos.com. And as we get to desmos.com, we're going to get this screen that says, let's learn together. We're on a mission to help every student learn math and love learning math, just like AskRose wants to help you guys learn to love math, because it's a really cool tool that can teach you so much about the world. So we're going to click on this button that just says Graphing Calculator, and that's going to bring up this picture of a graph. So this really cool thing is that if we type in the relationship that we just found, so on the left bar here we have a place to input our equations. So we type y equals 3x plus, which you can get by holding your shift key and then the equal sign on your keyboard if you don't know how, and then a 5, we're going to get our graph. And if we zoom out, we can find that number for any number. And it goes on basically forever. Desmos will continue to graph it, so that way you can find out in your x-intercept how many number of customers, how many burgers you need to sell to those customers, how many burgers you need to make. So we're going to ask a question here in the chat, and this question is y equals 3x plus 5 a function? So for those who've already learned a little bit of algebra, I hope you know the answer, but if you don't, that's okay, we're going to cover it. A function is a really cool concept. A function is we can leave that blue because it's a very important word, and then I'll switch back to black for the definition. A function is, I've lost my mouse here, hold on 1 second. Okay, so a function is essentially a way of visualizing inputs and outputs. And all it really means is that for every single input, we have only one output. So for every input, we have one output. And now you might be thinking, well, okay, maybe you've answered the poll and you've said that yes, you know what a function is, and yes, it is a function. But if you didn't and you got that wrong, that's okay, because we're going to cover what a function is and why that's a function. So y equals 3x plus 5 is a function, but why? So for every input, and our inputs here are x, if we remember back to kind of the graph terminology we're using, where x is an input, our number of customers, and our output is y. Our output is y. So what this means is that for every input, we have exactly one output. So for every value of x, we're only going to get one value of y, right? If I plug in x equals 2 and x equals 4, we've gotten a different number of y. It's not going to be the same y. There can be functions that are, there can be equations that are not functions, but we'll get into that a little bit later. For now, we're mostly going to be working with functions. And the idea of a function that's really cool is that every function has exactly one input and one output. So it's kind of a treat to leave you guys with. If we go back to our Desmos window, a function notation would be able to say, like, instead of y, we're going to have y be a function of our input x. So y is f of x. And that's probably some tricky notation that you guys might not have seen before, where we have an f and then in parentheses an x. That just means that f is a function of x. And the really cool thing about this in Desmos is we can actually solve for that value then by saying, like, what if we had 100 customers, we want to figure out how many burgers there are. So we can type f of 100, and it will tell us that we have 305 burgers. So that's a really cool way of using functions to solve really big numbered equations that maybe we don't want to plug in by hand, or maybe we don't want to think about getting to ourselves. So we can just solve a much easier equation and figure out a relationship like 3x plus 5 and turn that into something like Desmos, which can give us a much bigger answer. So that's about all we're going to cover for tonight. Next week, we'll probably get a little bit more into functions, maybe some more complicated equations, graphs, problem solving, maybe some fractions. Thank you so much for watching the AskRose live stream. I hope you guys have been having a great time. You can always find us on Instagram, Twitter. Make sure you submit questions to the stream if you'd like us to answer them live. And if not, then if we don't get to them on the stream, then you can always call us. Our doors open right now at 7 p.m. Eastern Time, and we're open till 10 p.m. Sunday through Thursday. Awesome. Have a great night, guys. Thank you so much.